Hello, everyone. Here we look at solutions to quiz 4. Let's look at the first question. So this is arithmetic problem. It's kind of straightforward. Right, so the problem says Mackie's car can go 32 miles on 1 gallon of gas. So 1 gallon can go 32 miles and it costs $4 for 1 gallon. All right, so now Mac has $20, right? So $20 is, which is 4 times 5. So clearly, so she could buy 5 gallon of gas, right? Gallons of gas. And this can go, because each gallon can go 32 miles, so 5 gallon obviously should be 5 times 32, which is 160 miles, right? So that's the best she can drive, given she has $20, right? Okay. Now let's look at problem 2. Problem 2 is a problem on number theory. So it says we have a part integer, which is n. N plus its second largest divisor equals 22. Then the question is, okay, we need to figure out what this part of integer is and how many divisors it has, right? Okay, so first of all, we know, because clearly, so the second largest divisor of n, this one is, of course, is less than n, because n, the largest divisor is n, and the smallest is 1. Okay, so the second largest definitely is less than n. All right, so then this tells us n has to be bigger than 27 divided by 2, right? Okay, because it has to be bigger than half of it. Okay, well, what's this one? Okay, so this is 13.5, so we get n is at least 40, right? Okay, so what are we going to do? Well, there's a shortcut to solve the problem using algebra, but here we'll do just kind of brute force. I'm going to list out all numbers from 14 to 27, and then just find the one that works for us. All right, so I'm going to do brute force. So let's list out all numbers. So from 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, right? Okay, so these are all the possible candidates for n. Now let's see, for each of these, what is the second largest divisor, okay? So we look at the second largest divisor, okay? All right, so the first one, the 14, the second largest is 7. Okay, and for 15, the second largest is 5. For this is 8. 17 is a prime number. It has only 2 divisors, 1 and 7 itself. So this one is 1. 18, this is 9. 19 is again is prime number, so it's 1. 20 is 10. This one is 7. This is 11. 23 again is prime numbers, so it's 1. This one is 12. This one is 5. This one is 13, and this one is 9. All right, so then you see we need to say first the requirement. N plus is the second largest equals 27. So then let's see if we look at all those candidates here. Obviously, there's only one that works for us. That's 18, right? Because 18 plus 9, which is exactly 27. Okay, so based on this, we figure out this n equals 18, right? Equals 18. Okay, so then we just need to figure out the number of divisors that 18 has. So let's look at all its divisors. 18, start from 1, right? And then we have 2, and then we have 3, have 6, have 9, and the last one is 18 itself. Okay, so in total is 6, right? 1, 2, 3, 4, 5, 6. So the number of divisors equals 6. That's right here. Okay. All right. Now let's look at problem number 3. So for problem number 3, here the key point is we need to remember the definition, and the definition of this sign, which is the square root, right? So square root is, well, we say the square root of 16, which equals 4. That's because 4 squared equals 16. So the square root of 16 is 4. Now the square root of 4 is 2. That's because 2 squared equals 4. So then we get the square root of 4 is 2. So square root is kind of the inverse, the reverse of the square. So that's how we define the square root, right? Okay, so now in particular, the square root of 100 equals to 10 because 10 squared equals 100. So you take the square root is 10. Okay, so that's what this notation, the square root, this is we call, right? So this guy is called square root, right? Okay, so this is what it stands for. All right, now, so here, let's go back to this equation. So square root of 16 minus square root of 4 equals square root of 100 minus square root of something, right? So this is what we need to figure out. All right, so as we did over there, so this one equals 4, this is 2, equals this one is 10. Okay, so we get this guy, obviously, this guy has to be equals to 8. Okay, so the question is, if I know the square root of n equals to 8, what is n, right? And we know 8 squared equals 64. So the square root of 64 equals 8. So n, we get n equals 64. Okay. So here, as I said, the key point is we need to understand, or we say, remember the definition of the square root. So that's kind of the reverse of the square. All right. All right, so now let's look at problem number 4. The problem number 4 says, Edward has a pile of marbles. If she counts by 3, there are 2 left. If she counts by 4, there are 3 left. If she counts by 5, there are 4 left, right? Okay, so, well, this just means, if we translate this into the language of remainder, it just means, okay, I have this number. The number when divided by 3, the remainder is 2. The number when divided by 4, the remainder is 3. And when divided by 5, the remainder 4. Okay, so of course we have, there are a lot of options for this kind of numbers. So here we have an extra restriction. It says the number is between 170 all the way to 190. All right, so then we need to pick out the one that satisfies those requirements for remainders. Now, what we should do, of course, one way you do is, I just go with brute force. So here we have 21 numbers. We check one by one to see which one works. Well, you can do that. Or we can do a shortcut. We first figure out, so first find all numbers within this range that have remainder 4, which is 4, when it's divided by divided by 5, right? Okay, so which means we only focus on the last requirement of the remainder. All right, so let's do that. So 170, so this one is divisible by 5, right? So it's just 5 times 34. So the next one, when you need the remainder 4, so you just add a 4, right? Just add a 4. Okay, so the first value one will be 174. Okay, so that's what we want. You add a 4, and then you add a 5. You go up by 5. So this is 179 and 184, right? Okay, so we have 3 numbers. So we have only 3 numbers. They satisfies the requirement. When they are divided by 5, the remainder is 4. And also they're between 170 and 190. All right, so let's put those numbers here. So we collect those numbers, 174, 179, and 184. Now let's go back to the other 2 requirements. It says when divided by 3, the remainder is 2. When divided by 4, the remainder is 3. So you check, because you only have 3 options, right? So it's not a big deal. You check each one, and you find, and we quickly identify, okay, so this is the one that works for us, right? So this one, when divided by 4, the remainder is 3. When divided by 3, and the remainder is 2. Okay, so we get the number of pile right here. This one equals to 179, right? 179. Okay. All right. So then the product of digits, the product of digits is, this one will just be a product, is just 9 times 7 times 1, which is 63, right? 63. Okay, so let me summarize. So here the point is we have 21 numbers, 170 all the way to 190. We need to find the guy that when it's divided by 3, the remainder is 2, when divided by 4, the remainder is 3, when divided by 5, the remainder is 4. So what we do is we first focus on the requirement when divided by 5, the remainder is 4, right? So 170 is divisible by 5. So the one that when it's the remainder 4, just add 4. So that's 174. The next one is just add one more 5. You just add one more 5, right? So okay, so we find a 3, right? So we find a 3. And for those, when they divided by 5, the remainder is 4, right? So the remainder is 4. Okay, so then we only need to look is check this 3 to figure out the valid one. Okay. All right. Okay, so here it says we have a square, which is A. The side length is 10. And then we have two smaller squares. One is the B, and the other one is C, right? So this is, I say B, and this is C. So I use the lowercase to denote their side lengths, B and C. Now we know the area, the sum of areas, so it's equal. So in terms of areas, okay. Right? So the area of this is just 10 to the squared, right? Which is 100, 10 times 10, and this equals. This is B squared, right? So this is the area of B, and the plus, this is the area of C, which is C squared, right? All right, so basically we are looking for integers, part of integers B and C, such that the sum of the squares is 10 squared, which is 100. Now, of course, what you can do is obviously, so here you have the B and the C, they are less than 10. You can do brute force, just try one by one, test to find that, right? Okay, so one is you say, okay, you just brute force to get B and C. And number two, if you remember, we have a famous right triangle, we say Pythagorean triple. So if you recall, 5 squared equals 4 squared plus 3 squared, right? So this is the most famous Pythagorean triple. And then if you compare this, you say, okay, 5 to 10, 4 to B, 3 to C. So, okay, great. So I can, this is just multiplied by 2. So I say, okay, so my B, I can just choose 4 times 2, which is 8. I can choose C is 3 times 2, which is 6. And you can check, you say, okay, this indeed, because this 10 is 5 times 2, right? All right, so then you can check this 10 squared indeed is 8 squared plus 6 squared, right? Because this guy is 100, this is 64, and this is 36. All right, okay, and this is the only valid option that works for us. Okay, so we get these two things. Now, of course, you might ask, why the B has to be 8? Why cannot B to be 6? C to be 8, sure, you can switch, doesn't matter. But here, what we ask is the sum of their lengths. So I will say, or you can type B equals 8, C equals, B equals 6, and C equals 8, doesn't matter. So because the sum of their side lengths is all 6 plus 8, which is 40. Okay. All right. Okay, so problem number 5. So here we have part of integer that has 4 digits. So we have 4 digits, 1, 2, 3, 4. And we know the product of this 4 digit, of its 4 digits. So if we do the product, okay, so this is my n. So if I do the product, this one equals 60. Now again, of course, so this just means we do the factorization, we write 60 as the product of 4 numbers. I mean, there are multiple ways to do that. So here what we're looking for is among all those possible choices, we are looking for the greatest one, right? The greatest one. Now, if you want the greatest one, of course, we want the 1,000 digit to be as large as we can. So given the 60, when you factorize this, what is the largest one, which basically is a factor of 60, right? So we are looking, so this is the largest factor factor of 60. So you say, okay, clearly what you can put here is 6. That's the best I can do. Then the other 3, so these other 3, so they multiply together. These 3 will be 10. So I'm going to do the same thing. Say, okay, ask myself, okay, 10. I'm going to factorize this, and I'm trying to find the largest way so that I have this 3-digit. Well, obviously, what should I do is I should put this one as 5, right? So this one times 2 times 1. Okay, so combine all those reasonings together, we should get this is 5, this is 2, and this is 1. So n equals 6, 5, 2, 1, right? So the sum of digits, if you add together, 6 plus 5 plus 2 plus 1, which is 14. So this problem is basically factorization, right? So it's factorization of 60. I say factorization of 60, but in a way so that if we combine into a 4-digit number, we just want to do it as large as possible. Of course, there are many different ways to factorize 60 into 4 numbers, but here the point is I just want it to be as large as I can, right? So that's why I put the first digit, the 1000 digit to be 6. All right. Okay, so number 7. So here we have a sequence of pictures. So each picture has the black square and the white square. So they are arranged in a certain pattern. Now we need to figure out. So here we have the first 3, and we need to figure out is the 15th one, right? Okay. Now we need to figure out the number of black tiles. Okay. So the point is, again, there are different people might have different perspective to think of this pattern. Now, what I want to do is this. Look at this. So say I have 2. So maybe look at 3. I think this is more clear. So if you look at this black tiles, so obviously it's 3 times 3 equals 9. And then of course you have the this middle ones, right? So okay, so those are 2 times 2 equals to 4. All right, so which means the third one is basically, it's just 3 squared plus 2 squared. Now, this one is similar. So if you look at this 2, okay, so that's 2 times 2, which is 4. And then you plus the middle one, so that's 1 times 1, just 1 itself. So which means for the second one is 2 squared plus 1 squared, right? And the last one is, the first one is just 1 squared. Okay, so if you think of this way, so it's kind of clear, which means if I go to the 15th one, so this one will be, follow this pattern, and this one will be 15 squared plus 14 squared, right? 15 squared plus 14 squared. Okay, so what's the 15 squared? So just 15 times 15, which is 225, and then plus 14 squared. So this is 196. So if you add them together, so it gets 421, right? Okay, so here, again, here the point is you need to identify a pattern that works for you, right? You can use different ways to do it. Doesn't matter. Just find one that you can work it out.